this portion of the video, we will be preparing the sample dilutions for the materials that you'll need to add to the plates. This will include the biotin-related molecule mixed with streptavidin-zap along with the controls. Let's get started. Transfer 10 to 15 ml of cell media into a fresh well reservoir. Now we will label the microcentrifuge tubes 1 through 8. The last one will be labeled ZAP only. In this section, we need the biotin-related molecule and the streptavidin-zap that came in your kit. First, we'll use the amount calculated for your biotin-related molecule. This information was calculated on day 1 in the Excel workbook. For the biotin-related molecule I am using in this example, I need 3.5 microliters. Take the vial with the biotin-related molecule and vortex briefly. Take the amount calculated in the workbook and transfer that to tube number 1. Now we need to take the calculated amount of streptavidin-zap. Briefly vortex. Add it to tube number 1 and pipette up and down a few times to mix. Vortex briefly. We want the solution to react for 15 to 20 minutes at room temperature. Next, we'll add to the tube labeled ZAP only. Use the calculations from the Excel workbook and look at the volume of cell media alone that we need to add to the ZAP only tube. In my calculation, it was 149.2 microliters. Look again at the Excel workbook to get the amount of streptavidin-zap that was calculated and added to tube number 1. We will add that same volume into the ZAP only tube. In my case, it was 0.8 microliters. Pipette up and down a few times and vortex briefly. We will incubate that tube at room temperature for 15 to 20 minutes. Now we will transfer 135 microliters of fresh cell media into tubes 2 through 8. Let's open tubes 2 through 8. Transfer 135 microliters into each tube. Once we finish adding cell media to tubes 2 through 8, we want to bring up the final volume into tube number 1 to 150 microliters. Go ahead and consult the Excel workbook for the volume that was calculated. For this experiment, I need to add 145.7 microliters of cell media. Now let's cap each tube. Now it's time to begin the serial dilutions. Let's take tube number 1 and vortex briefly. And tube number 1, again, contains your biotin-related molecule that's been reacted with streptavidin-zap. From tube number 1, you will transfer 15 microliters into tube number 2. Vortex briefly. Now, from tube number 2, you will transfer 15 microliters into tube number 3. Vortex briefly. And lastly, from tube number 7, you will transfer 15 microliters into tube number 8. Vortex briefly. Now it's time to add our material to the plates. What we need is our plates. And we need the well template that comes in the kit. We also need all our dilutions from the Excel spreadsheet and some more fresh cell media. First thing we will do is place the well template underneath the plate. Go ahead and remove the lid and set that to the side. We're going to add to the media only control column, that is wells B2 through G2. We will add 10 microliters of cell media only to that column. Next, we will add to the other control column that is labeled ZAP only. This is column 11, B11 through G11. We will add 10 microliters of the ZAP only control to each of the wells. Now it's time to add our sample dilutions to the plate. We will begin with tube number 8. If we look at the template, we see that tube number 8 will actually go into column number 10. We will transfer 10 microliters from the tube number 8 into each well in column number 10. First, vortex briefly. Then begin adding 10 microliters to each well. We will continue with the sample dilutions using tube number 7 into column number 9. Again, we will transfer 10 microliters into each well. And lastly, for tube number 1, we will do the same. First, vortex briefly. Then, transfer 10 microliters into each well of column number 3. Once you've completed adding all your sample dilutions to the plate, replace the lid. And you'll want to transfer your plate into the appropriate growth conditions for 72 hours. In this section of the video, we will prepare the sample dilutions for the 2 negative controls. The first thing we need to do is remove the 2 negative controls that come included in the kit. The first one is saccharin alone. The second is either blank streptavidin sap or biotinylated IgG sap. First, we'll transfer 10 to 15 mL of fresh media to a well reservoir. Then, we will label our tubes 1 through 8. Now we will transfer 135 microliters of fresh media to tubes 2 through 8. Now we will prepare the saccharin control plate using the calculations from the Excel workbook. Into tube number 1, we will transfer 105 microliters of fresh cell media. Then we will transfer 45 microliters of the saccharin negative control. Vortex the saccharin control tube. Then take out 45 microliters and vortex briefly. Pipette up and down a few times. Vortex briefly again. To make the serial dilutions for the saccharin plate, we will transfer 15 microliters from tube number 1 into tube number 2 and repeat, transferring 15 microliters into each subsequent tube. Vortex briefly before each transfer. Finally, we will transfer 15 microliters from tube number 7 into tube number 8. To prepare the sample dilutions for the blank streptavidin ZAP or biotinylated IgG sap negative control plate, use the calculations from the Excel workbook worksheet number 6, Control Conjugate. For this example, I will be transferring 142.6 microliters of fresh media into tube number 1. Next, we will take the negative control conjugate included in the kit and use the volume calculated from the Excel workbook. Vortex briefly. In my example, I will be transferring 7.4 microliters of the negative control. We need to transfer 15 microliters from tube number 1 into tube number 2 and repeat this transfer into each subsequent tube. Vortex briefly before each transfer. Finally, transfer 15 microliters from tube number 7 into tube number 8. We will transfer the plate into the appropriate growth conditions for 72 hours.